Let's say that we have a clock right over here. It kind of looks like a pizza, but let's just say it's a clock. And we were trying to find out what is the angle between the hour hand at 12 o'clock. So that if the hour hand was at 12 o'clock, it would be here. And the hour hand at 4 o'clock. So if the hour hand was here, so this is the hour hand at 4 o'clock. This is the hour hand at 12 o'clock. And we want to find out the angle. We want to find out this angle right over here. So how would we do this? Well, we know that a circle is 360 degrees, right? So this whole circle right over here is 360 degrees. And notice how there's 12 parts to this circle, right? Because this is a clock. Remember, so you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 angles, right? So if you know that the circle is 360 degrees, and you know that there's going to be 12 hours, well, that means that when you simplify this out, if you plug it into the calculator, you're going to get that this is 30 degrees per hour. The circle is 360 degrees, and in this 360 degrees, it's split into 12 parts. Well, you know that it's going to be 30 degrees per part, or in this case, 30 degrees per hour, right? The hour hand, right, it moves 30 degrees per hour, right? So that means that this angle right over here is 30 degrees. This angle right over here is 30 degrees. This angle 30 degrees. This angle is 30 degrees. So 30 times 4 gives us 120 degrees. Now, when you say that this angle right over here is 120 degrees, you can also say that this angle formed right over here is actually 240 degrees, right? Because if you're going like this way, right, this creates this angle, but you can also go this way and you create a 120 degrees angle. But for now, let's just keep on with this answer, okay? So whenever we're going to be doing these types of problems, let's just pretend that this type of angle is our only solution. Let's just ignore that other angle. What is the angle of the hour hand from the 12 o'clock position at 7:30? So let's say this is 12 o'clock position and 7:30 is here. So we are trying to find this angle. How do we do this? Well, if the problem just said, what's the angle of the hour hand from the 12 o'clock position at just 7 o'clock, so just 7 o'clock, well, that's easy, right? Because we know that in our circle, we just said before that every hour is increased by 30 degrees because there's 12 hours in this clock, right? So it's 30 degrees per hour. So in this case, since there's 7 hours, well, 7 times 30 gives us 210 degrees, right? So far, we've calculated this big angle right over here. And we said that this is 210 degrees. But what about this? But the part that makes this tricky is this 7:30 part, right? This 30, it's 30 minutes. Right? It's 30 minutes. So how do we find out this tiny little part right over here, right? How do we find out the rest of this angle? In order for the hour hand to go across the circle 360 degrees, so a full revolution, right? In order for this hour hand to go one revolution around the circle, we said how it takes 12 hours, right? There's 12 parts to this circle, right? How many minutes is 12 hours? So we know that in 12 hours, right? We have 12 hours here, and we know that every 1 hour, there's 60 minutes. Right? There's 60 minutes in 1 hour. So doing the math, we get that there's 720 minutes. There's 720 minutes in 12 hours. So 12 hours is equal to 720 minutes. And because they're equal to each other, let's just substitute it here. So we have 360 degrees divided by 720 minutes. And doing the math, we get that we have 0.5 degrees per minute. So what this basically means is that every 1 minute that passes, well, it's going to be an extra 0.5 degrees. So for example, if let's say, I'm just going to do like a quick example. Let's say this is the 12 o'clock position. let's say this is 12 o'clock position, and I'm finding what's the angle created at 12:20, let's just say. All right, 12:20. Let's just say it's somewhere over here, right? Well, from 12 to 12:20, how many minutes has passed? 20 minutes, right? 20 minutes has passed. And we know that there's a 0.5 degree angle increase every 1 minute, right? So the clock every 1 minute, it rotates 0.5 degrees in the hour hand. So if you do the math, you get that it's a 10-degree angle. It's a 10-degree angle. So knowing this factor, let's come back to our original problem. We said how it's 7:30, right? So if we have 30 minutes, we know that our clock goes 0.5 degrees every minute. And notice how like the minutes cancel out, right? So you get 15 degrees. So that means that this tiny angle right over here that now we've calculated, it's 15 degrees. So that means that this whole big angle right over here is just gonna be 210 plus 15, which is just 225. I mean, this also makes sense logically. Some of y'all might have done this problem logically, and you said that, okay, we know that every hour, right, our hour hand goes 30 degrees, right? Every hour, our hour hand goes 30 degrees. Now 7:30, 30 minutes, we know that's half an hour. And if it's half an hour, then it has to be half the angle, right? So if we know that this is 30 degrees per hour, then we know that it has to be 15 degrees per half an hour, right? Per half hour. Because if the angle decreases by a factor of 2, then that means that this hour part has to decrease by a factor of 2, right? So it's 15 degrees per half an hour. And we know half an hour is 7:30, so, you could have done that here. But this conversion factor is important because what if you had, let's say, 22 degrees, right? And then after that, you would have to use this conversion factor. All right, let's say we want to calculate the angle of the hour hand from the 12 o'clock position. So we have 12 o'clock position at 8:22:45. What does this mean? Well, this all just means, if it helps to write it out like this, do it. So all this means is 8 hours, 22 minutes and 45 seconds. Now you might say, okay, I know how to deal with the 8 hours and 22 minutes part, but what do I do with the 45 seconds? Once again, we're going to use the same logic we did before. We know that in order for the hour hand to go 360 degrees, so one rotation around the circle, we know that takes 720 minutes. I was about to say seconds there. It takes 720 minutes. Now, we know that, so let's just say this is 720 minutes. We know that in 1 minute, it takes 60 seconds, right? 1 minute takes 60 seconds. So 720 minutes, so 720 times 60, that's 43,200 seconds. All right. Now, we know that these two things are equal to each other, so let's just substitute this in. So we get 600 divided by 432,200 seconds. And putting this into your calculator, you actually get a pretty small number. You're going to get 0.00833 repeating, 0.00833 repeating, 3 repeats on forever. Or you can write it like this. You can also write it like 0.5 divided by 60. These two things are equal to each other. And all this means is that for every second, well, your clock from the hour hand is going to move 0.0083 degrees, repeating on. That's basically what it means. Anyway, so this is equal to 0.5 divided by 60 degrees per second. All right, so if you want to write it as a fraction, go ahead. You write it like this. But otherwise, yep, we're ready to solve the problem. So let's break this up into 3 parts. We have the hours part, we have the minutes part, and we have the seconds part. So we know that 8 hours, how many degrees is that? Well, we know that it's 30 degrees per hour, right? So that means 8 times 30 is going to give us 240 degrees. So all we are saying is that if, let's say this is 8:22, well, 8 hours right over here. Let me do this in a different color. All this is saying is that 8 hours, first of all, this first step, that's going to give us 240 degrees. What about the 22 minutes? Well, we know that it's 0.5 degrees per minute. So 22 times 0.5 gives us 11 degrees. So that means this 22 minutes right over here, this is going to give us 11 degrees. All right. Now, what about the seconds part? So the seconds part is going to be this little part right over here. This represents the seconds. So for 45 seconds, what degree angle does this make, right? What degree angle does this make? Well, we said how it's 0.0083 repeating on degrees per second. So 45 times this conversion factor. Well, let me just put this into my calculator. So if I multiply this by 45, I get 0.375 degrees. So the seconds part has an effect of 0.375 degrees on the angle. So the seconds part right over here has this 0.753 degrees effect on the circle. So now to find out everything, well, we just add all these parts together, right? Because if we want to find out this big angle right over here, well, it's just going to be the sum of all these smaller angles, right? All these individual parts that we've done. So yep. All right, the math's correct. And yeah, so this is the angle from which we compare it to the 12 o'clock position. So it's this big angle right over here.